Welcome to today's webinar. My name is Jim Stankham. I'm the Director of Relationships for DAD. We have attendees here online from here in Perth, and we also have attendees from across Australia and some dotted around the world. So welcome to you all. I'm looking forward to discussing the recent use of DAD on a major iron ore project here in Western Australia. Our agenda for today's webinar, I'll provide a brief client background and project overview, and then we're going to have a Q&A session with Leah Kennedy. Leah is a lead designer and DAD expert, and Leah played an important role in the project that we're talking about today. We'll finish with a Q&A with webinar participants. So please use the Q&A button across the top of your Teams webinar screen throughout the webinar, and we'll address as many of them as possible at this point of the webinar. If we're unable to get to all of them within the 30-minute time frame, we'll come back to you individually, and where applicable, we'll share the answers on our LinkedIn page, similar to our previous webinars. DAD was featured in last month's edition of the Australian Mining Magazine. The theme of the May edition was efficiency and optimisation, and the feature article focused on how DAD streamlined the engineering and management processes on a major iron ore project in the Pilbara region. If you haven't already read this article and would like a copy, please let us know and we can get one to you. For those who are not familiar with DAD enables complex systems to be digitally modelled and managed throughout the life cycle. A system model contains all current and historical hardware and software information about objects, equipment, cables, etc., their connections and their relationships. It creates a centralised database of extensive system information and is the central tool used by everyone involved with the system, from designers to engineers to managers. The case study featured Fortescue's $4 billion Greenfield Iron Bridge project, which is now in operation. Having successfully used DAD on other projects and sites for more than 10 years, Fortescue understood its value, so it was an easy decision for them to again turn to DAD for this iron ore project. They are change leaders in this space. To discuss this in more detail, I'd like to welcome Leah Kennedy. As mentioned, Leah is a lead designer and DAD expert. Welcome, Leah.
Hi, Jim. Hi, everyone.
Great to have you with us today. Let's kick off in terms of, can you just describe the role that you played with Fortescue on this project?
Yep, sure. So at the very beginning of the project in 2019, I was initially brought in as DAD support and training to the design contractors and to various Fortescue teams. And gradually, as the project evolved, my role expanded to be part of the design team, and just finished at the beginning of 2024 as operations was handed over, hand over to operations.
Excellent, thanks, Leah. How important was it to have a DAD expert within the team?
I think in this case in particular, because of my experience with prior Fortescue projects, I brought experience of the structure of previous sites. I had design experience with Fortescue on previous projects. So I brought that level of experience with both DAD and also with Fortescue and their systems and processes. And then, of course, the training aspect. Each new project brings new teams of people that haven't been exposed to DAD. So that training was also an invaluable aspect.
Excellent, thank you. Just another question there, Leah. You talked about your previous experience with Fortescue. How would you describe, might be on people's minds around their expectations of, as the asset owner, of deliverables over time? You've been involved with them for a period of time. I can imagine there was a bit of change there within Fortescue around what they expected as deliverables project to project over time.
Yes, absolutely. The very first project that we did with Fortescue, so the first project that used DAD was the T11 port expansion. I think that's what it was called, the project name. And right back at that stage, contracts were in place, and the contracts were in place for deliverables. So DAD was used to actually produce drawings because contracts were set up to for these various contractors that were involved to produce deliverables. So gradually over time, since that very first project, we've implemented DAD more and more. Contracts have changed, procedures have changed, and as people embrace DAD more and more, we use it more in the way that it is intended, less external drawing deliverables and more about delivering a DAD model.
Excellent, thank you. I think that's an important evolution that you've touched on. Let's talk about the design phase. And surprisingly, when following the traditional process, teams of engineers draw the designs for these complex systems in a flat manner, much like a picture. And this approach creates thousands of individual documents and drawings produced by different teams working on the system, all of which capture little bits of information about it. With this particular project, how was DAD used to engineer differently to these traditional methods?
Well, firstly, we probably produced very few drawing outputs. It really was about sort of not producing any outputs, giving people access to the DAD model, and not having a whole host of deliverable drawings. And this was a very large scale project. I tried to get some figures for us so we can understand the scale. And this was 50,000 cables approximately, 30,000 instruments. We're talking very large scale. And we produced very little outputs from DAD. Majority of people were given access to the DAD model, and everybody referred to that for their information.
That's some great insight, and certainly shows the extent of the size of the project. Just as a follow-on question there, Leah, I'm sure change management is going to be on people's minds here. The traditional decentralized approach around drawings and documents makes managing change inherently difficult, slow, and often error prone. But in this case, without drawings or controlled documents, how was the review and approval process handled, firstly, and how did Fortescue ensure that the information that they were giving people was the latest and most up-to-date information?
Yes, so we implemented a process or a procedure essentially with using DAD. What we wanted to do, because traditionally we revision control drawings, so we have to have a way of controlling this information, making sure it is correct, getting reviewed, getting checked. And so we did that within DAD. And that was done by reviewing the object and revision controlling the object. And when I say the object, I mean the cable, the pieces of equipment. Everything was given a revision, and it went through the process like that. And also, just as a side note, when it was given to the constructors, so the construction contractors, they were given frozen snapshots. So that had been controlled, reviewed, they were given this frozen snapshot and were able to see all the revision and changes in DAD themselves. And we also produced a spreadsheet, a weekly spreadsheet of all the changes. because this was a fast-track project. Design and construct were happening simultaneously.
Excellent, thanks, Leah. That's good insight into that particular process. I just want to remind participants again, the Q&A function at the top, if you've got questions on your mind that you would like answered while we've got Leah with us, please type them through that particular function. All right, let's move on in terms of access to the model. So with everyone involved on the project working together on the one model of the system, how was access to the model managed, Leah? And what were the access levels and who actually managed it?
Well, in this instance, we hosted the DAD database on servers that allowed global access. And this was really important in this instance. The design contractors were spread across the world globally. So we had people in South Africa, India, Canada, America. And we needed to be able to provide access to these people from all over the world. So we managed that. We hosted the DAD database, and as instructed by both Fortescue and the design contractors, we added the users and assigned their rights according to the requests. So that basically meant that everybody who had access, whether it be read or write or view or edit, they were able to access and see all the latest information. It didn't matter what time zone you were in. Whenever you logged in, you were going to see 100% of the information at any time. And it's important actually to note here that, we had 200 to 250 users of DAD at the peak of the project. And at that point, there were probably only 15 to 17 edit licenses. So, it was a very small team that was doing the editing within DAD.
Yeah, that is great insight. And that might not be what people naturally think in relation to that a small proportion required edit access, but obviously a high proportion needed to be able to view the information, but not necessarily change it. So thanks, that's good insight there, Leah. Let's move on in terms of, I'm assuming not everybody had access that was involved in the particular project. So how was information shared with people who didn't have access?
Yes, so we did have some smaller contractors that were involved around the pipeline and other areas, and the panel builders is also a good example. So in those instances, we produced work packs. And when I say work packs, it was essentially a cover sheet with a DAD PDF output attached to it, and then it was provided to the various contractors.
Okay, excellent. Thank you. There's a key pain point for asset owners is often the poor quality of as-built information that gets handed over to them at project completion, meaning they either can't trust the information or find it, or often both. How did DAD solve that problem on this particular project?
So while the fast track project provided some challenges, design construct is happening simultaneously, it actually resulted in a level of as-built information during that stage. And what I mean by that is we had this kind of feedback loop. We would provide updated information weekly to the installation contractors, and then the contractor would feedback updates or modifications through DAD markup. So we had this whole process, a weekly process. We would provide updated information. The contractor would then provide us with marked up DAD outputs. So in essence, it kind of provided benefits because of that very process, which is interesting. And then once it's sort of handed over to operations can just come in, simple searches within DAG, tag searches, equipment searches, any number of searches, and find the information and be happy, be more confident in the fact that it's going to be updated because we had this process.
Yeah, that's great, and recognizing that that is a key pain point to be able to understand how Dad's been able to overcome that on this particular project. We're going to jump into Q&A. We have Leah on hand to be able to answer your questions. There are a couple of questions that have come through that I think, Leah, it's worth answering up front. They're good general questions. The first one is, if you were to describe a couple of the key benefits for Fortescue using DAD on this particular project, what would you point to?
Well, I would point to sort of the accuracy. And when I say accuracy as well, it's important to note, I think with DAD and with this sort of single source of information, a one-to-one relationship with the real world, what you get is an inherent accuracy. It will be right or it will be wrong. And because of this feedback loop that we had with the constructors, with the installation contractors, we basically, if we provided them with information and it was wrong, because there are numerous situations that happen, you get vendor supplied packages, they arrive at site and they're different from what is expected. And so through this sort of feedback loop, we were able to really know that it was either right or it was wrong. We had one instance of it. It was a one-to-one relationship. And so we really got that accuracy. And then obviously, because we were doing this fast track design, construct, all happening simultaneously, that ability to quickly change, the speed with which you could update the information, and then the speed with which you could relay that information to whoever you needed to. And that sort of whole, create, edit, find, share, that whole process was very quick. And actually another benefit that I'm sort of thinking of at the moment is there is something inherently valuable about the process of putting the design into DAD that gives you intimate knowledge of the actual systems, because these are not lines on a page. These are not CAD drawings where people are just drawing lines. You have to know what you're doing. You have to understand the bits of equipment, what type they are, their connections, how they're powered, etc., etc. So that process of doing the design within DAD gives people a wealth of knowledge about the systems. And it's very hard to explain that, but I know we've got a couple of clients that also agree. There is something about the way that DAD gets you to design or gets you to put the information in that just really gives you a solid understanding of your systems.
It's a great point, because often these systems are a key blind spot for asset owners, which makes them vulnerable. But interestingly, the physical aspect of the asset is really nothing without the operation of these systems behind it. So it's a great point that you touch on there, Leah. There's another question in relation to not necessarily the reverse of that question, but in relation to what were some lessons learned from using DAD on this particular project, appreciating that Fortescue have history here in terms of their evolution with DAD, but I'm sure, as with any project, there were still some valuable lessons learned.
Yes, absolutely. Well, we touched on it earlier when, so even though there is a history within Fortescue for using DAD, every new project brings new people. So even though Fortescue has been using DAD for quite some time, these teams that arrive, new design contractors, possibly new electrical contractors, all these sorts of things mean essentially you're starting from scratch. So creating processes and procedures, ensuring you have training are really important things for this. And I also just wanted to touch on, when you start to export information from DAD, you really need to manage and control that as well, because as soon as you take it out of the model, you lose that sort of live updating of information. So you need to ensure you have good processes around that. And I think also, and this was something that Fortescue already had, they have basically a guideline, a specification for the structure of DAD, and that's quite important. And certainly where we've provided input to help them create a good structure. So when I say it's very hard if you haven't been experienced to DAD or been involved, but it is basically the bones of it. So how you create this information, how you build your information, and having good structure will really ensure you reap the benefits further on. So yeah, I think that's probably all I can think of off the top of my head.
Excellent. No, that's good. That's a good insight into some of the key benefits and a couple of the lessons learned. I'm going to jump to a question, one of the questions that's come through the Q&A. I'll just read it as it's come through, Leah.
Mm-hmm.
I love the central source of data model approach and reduction in drawings. How, for example, are things like electrical schematics produced or replaced for operators and maintainers to understand the functionality of a given circuit, for example, including interlocks, timers, isolations, etc.?
Yeah, okay. So in this instance, and it's worth noting here, for this is how we approached it for Ironbridge, and not only for Ironbridge, for previous projects with Fortescue. What we typically did was we had a schematic outside of DAD. So that's basically what we did. We had, what is the word I'm looking for? We had typical schematics for each of the drive modules, and that is how we handled it. So in DAD, what would happen, the cables would come and terminate to the terminal strip within those drives, and then we would have a corresponding schematic, an AutoCAD or a MicroStation or whatever drawing, and then we would reference it within the DAD model. So you can provide, well, you can do numerous things. You can provide hyperlinks, which could take you to the schematic in your file system, or you can just reference the drawing number. But that is how we handled it for those types of circuits and schematics.
Excellent. Thanks, Leah. A good summary there. We're almost out of time. If there are other questions, we certainly encourage those to come back to us individually. So we intended to keep this brief to be able to give you some further insight beyond the article and the opportunity to be able to hear from Leah. But we'd love to do a demonstration for you that is customized to your key opportunities or challenges. If you'd like a demonstration or any other information, including a copy of the article that we referenced, please reach out to us directly by phone to our head office in Perth. Alternatively, you can contact us via email, sales@dad.net.au, or via the contact page on our website. We also encourage you to follow us on LinkedIn. So thank you. We appreciate your attendance today, and we will get you a copy of this recording for your own purposes, but also that you're able to share with your colleagues. Have a great day.